Welcome to the Explainer. All right, so if you're a developer building with AI, you're constantly asking one big question. How do I get more out of these models? Well, today we're breaking down Anthropic's playbook for exactly that. They've laid out a really clear three-pillar strategy for evolving their platform to help you build smarter, more powerful AI agents. Let's get into it.
So what's the big idea here? What's driving all this? Honestly, it boils down to this one phrase: raising the ceiling of intelligence. This isn't just about small tweaks. The whole goal is to give developers on the front lines, the ones pushing the limits, the power they need to build truly high-performing, next-generation AI systems.
So how are they going to do it? Well, Anthropic's whole platform strategy rests on three core pillars. And to make this super clear, we're not just going to talk theory. We're going to follow a real-world example they use, an AI coding agent called Claude Code. It's the perfect way to see how all this stuff actually works in the wild.
Okay, let's jump into the first pillar, harnessing capabilities. This is all about letting you, the developer, tap directly into what Claude is already really good at. It's about giving you the levers to control its core strengths, the things it was trained for.
A perfect example of this is thinking time. It's kind of like this. The more time you let Claude think about a tough problem, the better its answer is going to be. So the API puts you in the driver's seat. Need a super fast, simple answer? You got it. But what if you're wrestling with some gnarly bug? Well, you can tell Claude to take its time, use more tokens, and really reason through it. You get to control that trade-off.
And then there's tool use, which is a huge one. Claude has gotten incredibly good at knowing when it needs to call a tool. It could be something built in, like a simple web search, but, and this is where it gets really powerful, you can create your own custom tools. You just give it a name, a description of what it does, and what it needs to run, and boom, Claude can use it like it's been there all along.
And this is exactly what our example, Claude Code, does all day long. I mean, it relies heavily on this. It's constantly using a whole suite of custom tools to do its job. Things like reading files, searching through the codebase, writing out new code, and then, get this, it even reruns the tests to check its own work. Pretty cool, right? All right, let's move on to pillar number 2, which builds on the first one and is just absolutely crucial. It's called managing context. Because, let's be real, an AI is only as good as the information it's looking at. This is all about making sure Claude has the exact right information in front of it at the exact right time.
So, first things first, how do you get information into the context window? That's where something called the Model Context Protocol, or MCP, comes into play. Just think of it like a universal adapter. It's a standard way for the agent to reach out to other systems, say GitHub or Sentry, and pull in exactly what it needs, whether that's the latest code or some fresh error logs.
Okay, but you can't just shove everything into the context window, right? It would get way too crowded. That's where the next tool, memory, is so smart. It's basically like an external hard drive for the AI. Claude can save important stuff there for the long haul, things like your personal coding preferences or project-specific rules, and then it's smart enough to pull that information back in only when it needs it.
And finally, you've got to keep things tidy. That's the third part, context editing. Think about it. An agent might run a tool and get a massive chunk of data back. After a while, that data is just old news, but it's still clogging up the context window. This feature is like a Roomba for the context window. It goes in and cleans out all the old, useless stuff that's just taking up space.
So, does all this tidying up actually matter? Oh yeah, get this. On their own internal tests, just combining memory and context editing together boosted performance by a whopping 39%. That is a huge deal.
And this chart right here just proves the point. Everyone in the industry is always talking about bigger and bigger context windows. But this shows that just having a giant window isn't the whole story. What really moves the needle is actively managing what's inside it. A clean, focused context is the secret sauce for getting better performance. Okay, so that brings us to the third and final pillar. In this one, this one is a real game changer. It represents a totally new way of thinking about how we should be building these AI agents. This quote just says it all. Give Claude a computer and just let it do its thing. I mean, think about it. For so long, developers have been stuck building all this heavy, complex scaffolding just to make the AI do anything. The big shift here is to stop doing that. Instead, what if we just gave it the keys, give it a computer and the autonomy to figure things out itself?
This really is a whole new paradigm. The old way, you, the developer, had to build and manage everything. The complex orchestration, the servers, the security, all of it. The new way, you hand all that over to the platform. Anthropic provides a secure, sandboxed environment, and you just focus on what you want the agent to do.
And a key piece of this puzzle is the code execution tool. This is huge. It doesn't just let Claude write code, it lets it run that code. And it does it in a safe, sandboxed environment that Anthropic handles completely. So you don't have to spin up containers or worry about security vulnerabilities. It's all taken care of for you.
But it gets even better. You can supercharge this setup by giving the model what they call agent skills. Think of these like prepackaged toolkits or playbooks. They're basically folders full of scripts, instructions, and other resources that give Claude deep expertise in a specific area, ready to use inside its little computer.
So, for example, imagine you create a web design skill for your company. You pack it with your design system, all your approved layouts, your logos, everything. Then next time you ask Claude to build a landing page, you don't have to explain anything. It just knows to grab that skill and bam, the page it builds is perfectly on brand, following all your rules automatically.
Okay, so let's pull this all together. We've got harnessing capabilities, managing context, and a computer for Claude. What does this actually mean for you, the developer who's sitting down to build something with this?
Well, it boils down to this. Each pillar gives you a serious leg up. Pillar 1 gives you direct control over Claude's raw power. Pillar 2 lets you squeeze out every last drop of performance by being smart about context. And Pillar 3 lets you build truly autonomous agents way faster without getting bogged down in infrastructure.
And here's a really important thing to remember. This isn't a one-and-done kind of deal. Anthropic is very clear that this whole three-pillar framework is designed to evolve. So as the AI models themselves get smarter and more capable, the tools and the platform will grow right along with them. When you look at this whole strategy, it's really pointing towards a pretty incredible future, right? We're talking about a future where AI agents can tackle really complex, multi-step problems with way less hand-holding from us.
You can almost see the story unfolding. Right now, we spend all our time building this heavy scaffolding around the API. But soon, we'll be using managed platforms to just give the agent tools and its own computer. And where's that headed? To a future where these agents can operate almost completely on their own, using their deep expertise to solve problems we can barely imagine today.
And that really leaves us with a powerful final question to think about. The big question for all of us is shifting. It's no longer just how do I build the infrastructure, it's becoming what amazing things can I build with it. So when an AI can use its own computer, what problems will it solve next?